Hello, and thank you for joining us as we introduce the new glTF Asset Auditor. Our presenter today are the Vice Chair of the 3D Commerce Working Group, Mike Festa from SuperDNA 3D Lab, and Eric Chadwick from Wayfair, who is the co-chair of the Asset Creation Task Subgroup. First, a couple of housekeeping items. If you have any questions during the presentation, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. We are recording this webinar, and we'll share the link along with the slides and the recording. At the end of the session, please complete the short survey form to help us better design future events. With that, I'll hand it over to Mike Festa from SuperDNA 3D Lab. Mike?
All right. Hello, everyone. Thanks for joining us today. I'm going to just take over screen share. And let's see. I'm going to share my whole desktop because there are a couple of things that we're going to do for live demos. So get the presentation. Cool. All right, welcome. Yeah, so here's an overview of today's agenda. We're going to talk a little bit about the origins of this tool. Where did it come from? Why does it make sense to us? Why is it important? We're going to then go through some of the initial requirements, talk about the current features and checks that are available, go through a live action demo, seeing it on the web, look through some of the code on GitHub, and then also give a demo about how you can use this on the command line for integrating it with, your pipelines or automation for either content creators who are validating content that's going out to the web, or for folks that are ingesting content and looking to put that into a live app or experience. Towards the end, we're going to talk about some future developments and have a call to action about, submitting your own asset profiles that can be shared and give content creators more targets to kind of hit. And then we're going to finish up with live Q&A. Feel free to ask your questions throughout this session. We may be able to address some quick questions as we're going. Otherwise, we'll probably save a few of them for the end. And those can include, specific technical questions. Kind of happy to step through code if that makes sense. We can also follow up offline if we start to get too much into the weeds. All right, so just a quick background about myself. I've been, doing 3D and, AR, VR gaming for a while now, I'd say about 20 years. I'm generally a software developer by trade, but I find a lot of, joy and value in kind of going out there and building these tools and promoting them. I was founding a team called Wayfair Next back in 2015 out of some hackathon projects that I had built internally. We did a lot of interesting things in the product visualization space. I left Wayfair to found my own company called 3XR. We were a startup that was, venture funded. Unfortunately, we didn't get the right timing or market traction. So we did shut down the business, but I've been continuing that kind of work with one of my latest projects, 3D Model Foundry, which I'll give a partial demo of that today. I am the vice chair of the 3D Commerce Group, which we'll also talk about a little bit later. And one of my fun projects I'm working on that you'll hear more about in the next month or two is an AR/VR game called Paint Fiesta that, again, you'll hear some more in the next couple months. But yeah, that's about me. I'm going to pass it over to Eric Chadwick, who's also co-presenting and working with me in this content in Khronos. So go ahead, Eric.
Awesome. Hey, thanks, Mike. So I'm working at Wayfair as a technical artist here and kind of leading how to do real-time 3D modeling and for AR and VR and interior decorating kind of stuff. And also our rendering pipelines, we use V-Ray and 3ds Max and various other tools and kind of keep making sure that whole pipeline moves along really well. And like Mike, I come at it with a huge bunch of experience. Mine was in game development for a long time, doing all kinds of different stuff. And I'm regularly part of these Khronos calls that we have every week on glTF through 3D Commerce, and then the Asset Creation. I'm the co-chair of that group, which we'll talk about in a little bit. And we also have a 3D Formats call, which is all about glTF and how we can improve that whole ecosystem. And one of the subgroups of that is the PBR task subgroup, where we talk about the latest materials. And so I'm contributing to that, helping out. How do we do anisotropy? How do we do subsurface scattering, all kinds of things we're looking at there, which is great, exciting to see. And then finally, the tooling task subgroup, which is fairly recent, where we're identifying what tools that we need out there and how to kind of promote the glTF ecosystem with tutorials and demos and help people kind of understand and get past their roadblocks.
Excellent. Thanks, Eric. Yeah, so, as we mentioned, we're part of this group within Khronos called 3D Commerce. We meet every Thursday Eastern time. That's where Eric and I, but 11 a.m. Pacific, 8 to 9. Basically, a group of like-minded, retailers, tech companies, folks that are really trying to enhance product visualization and make things more universal and easy for, content creators or, even end users to basically take a 3D model that represents a real world physical thing and, project that into their space with AR, maybe interact with it in VR or in gaming, see it on the web, configuration. There are a lot of, interesting use cases that are both available today and kind of coming around the corner that, need real world products. So the 3D Commerce group within Khronos basically kind of, gathers those requirements, works with, some of the other teams within the Khronos organization to help deliver, roadmap improvements to formats like glTF, for example, so that, again, it's a voice at the table representing kind of that realistic product for, basically commercial purposes. And then the Asset Creation Task Subgroup, I'm going to let Eric speak towards since he's the co-chair of that.
Yeah, so we, in 3D Commerce, a bunch of companies, we came together to figure out, what are the challenges that we're trying to solve together. Even though some of us are competitors, right? We still have a lot of the same challenges to solve, and so it makes sense to come together and figure those out. So one of the things we figured out was, asset creation can sometimes be really difficult, especially at scale. And like Mike said, to reproduce real world products, that produces its own trials and errors. So that we formed the Asset Creation subgroup to meet twice a month to talk about, hey, what are the latest issues and how can we solve those? And so one of the things we did was develop these guidelines for how to create assets in the best possible way, such that they can be rendered everywhere. Render everything everywhere is kind of the general term, but it's basically, if we make an asset, we want it to be able to use it across the whole ecosystem. So if it shows up in a search, or if it's on a social platform, or if it's on our own website, if people follow that trail of picking up from an ad and seeing a live 3D product, well, do they see the same result going through all the various websites? And so the guidelines were an attempt at how to make it clear to others what the best path forward is. So we talk about physically based rendering and yeah, what are the right formats for the files, and how big should the files be, and how many polygons, and all those kinds of things, which really helps kind of clarify a lot of these issues. And you can see from the authors, we have a wide range of people that are hitting those things and trying to figure out, what's the best middle road to hit in all of this. And we'll share a link to this after the talk too. Yeah, cool. So one of the things we identified was, how can we solve the QA problem of when you make a whole bunch of different assets? You often, if you're a large company like Wayfair or Target or Facebook or any of these other companies, you're making a lot of assets and you're probably using a lot of outside vendors to make those. And then you have to do QA on those to make sure that they match your real world products. And so we identified that it'd be great to take a systematic approach to automating the QA of a bunch of assets. And we came up with a bunch of requirements for, hey, what should this do and how should it work? And it should be a standalone web page that people can just drag and drop their assets directly into it and try it out and see what it looks on individual assets. but it should also have a batch mode for a command line tool, so that you can run a whole bunch of files through it and get an automated, volumes of assets. And it runs the glTF validator first, which is the core tool just for checking is a glTF formatted correctly, but it doesn't really test the assets within it to see, how many triangles there are, or what color space the textures are in, or any of those things. It kind of looks at just the basics of what's in a file. It does check a few things, which is nice, like color space of textures and things. But we knew that we needed extra things on top of that, and that we knew that we wanted those to be configurable by the end user of the tool. And so that's where the profiles came in, which is to come up with a list of ranges. Like, for example, Wayfair wants 150,000 triangles per model, but IKEA might want a different range and Target might want another. So everyone's going to have their own profile to run with the tool that you want to save and say, oh yeah, this is the Wayfair standard, that kind of thing. So pass it off to Mike then to talk about that.
Excellent. Yeah, thanks, Eric. Yeah, I think that's good to just kind of have that background or perspective, thinking about why does the tool exist, and then looking more at, okay, so what does this tool actually do? So here's kind of a list broken down by kind of categories of the main checks that are available today. And so, as we mentioned, this kind of goes beyond what the existing validator would do, which is more about technical correctness. And here you start getting into a little bit more, artistic freedom / like opinionated, use case, right? So like the file size, doesn't really matter for a valid glTF file, but if you're trying to load something to a customer in a web or in an ad experience or something, there's going to be different requirements depending on kind of, your fidelity that you're looking for. You might have a budget for more triangles or more materials versus if you're trying to, let's say, populate an entire room, right? So you may need to limit it to a single material, for example. But if it's the hero asset and it's a, one-to-one experience, then you might want to have, more of that content, right? So we basically kind of broke, these areas up into categories. And during the initial process, when we were, looking at the requirements for this particular project, there were a lot of things that we ended up having to kind of like shelf and say, all right, let's limit the scope of work for V1, get something out there that people can kind of react to. So we know there's other, features that are important, and we're going to talk about those a bit at the end. And of course, value your feedback so we can have a kind of a dialogue as well as part of the Q&A session. But these are kind of where we landed for, this is something, immediate that we can provide value for. They're parameters that you don't necessarily just get from reading the file format. Some of them do take actually rebuilding the model. And this is something interesting that I learned while I was working with this project, is that the glTF file format itself, since it's optimized for running and loading into a GPU at runtime, doesn't necessarily have all of the information that you might have when you're working in a tool like Blender or Max or Maya, simply being able to check like the edge, for example, for beveled edges or, a hard, sharp edge. You have to know the distance between the two faces that intersect at a given edge. But by default, the glTF file doesn't have that information anymore. That's kind of been, thrown out. And we basically just have a list of vertices and faces. And so there's a process that this tool goes through that basically reconstructs and, calculates those edges. So that means that there are a few tests that happen that can be a little bit slow, which when I do the live demo, you'll see those are kind of indicated. But depending on, the use case, it might be really important that you don't, show anything with a hard edge, or, overlapping UVs is another one that can get recalculated as we're running the audit check. For some use cases, those might be really important. And if this is a batch process and it takes a minute or 2 minutes, it may not necessarily matter. But if that's not important to your company, you can run a lot quicker test if you don't do some of the reconstruction, which again, it's kind of mentioned in the code. But I want to just kind of call that out here. Cool. All right. Well, then we're going to switch modes and I'm going to do a live demo. I'm going to show kind of two different use cases of the web interface. When we built this tool, it was designed to just basically be like a reference design that you use under the hood. So we've got the JavaScript code that's the meat of the project. And then we've got this kind of web demo. On the left side of the screen, you can see the standard one that we've got out there on our GitHub. On the right side, you can see this 3D Model Foundry is kind of one of my projects, basically the spiritual successor to 3XR, which was all about content creation. So it's a little more stylized in that demo. But let's switch tabs. Tabs. Okay, get out of the presentation and go over to the auditor. All right, so here we are, Khronos.org. We've got the Asset Auditor live demo. The first step, we kind of broke this up into a couple of steps. The first step, though, is to select an audit profile. And, we're also encouraging you to kind of create your own. To create your own, you can just click the edit settings. If we don't click anything, it'll just run the default recommendation. But, we can kind of scroll down and see what are some of the different attributes. And this is kind of similar to the big chart that I showed originally of things that we can check, right? You can check file size. Here it's, 5 megabyte limit. You can maybe put a minimum too, right? So you might end up with files that are awfully small, like suspiciously small, right? That are missing, a texture or geometry or something. So you might want to have a minimum that you're accepting. And I should mention too, that like when you're using this auditor in production, failing a test doesn't necessarily mean you reject it outright. It may mean that, a specific test warrants additional inspection, right? So you may just pull something off that has too many materials or, the file size is a little big, and then put that into a different queue. Maybe a human reviews that content, or you could outright, send it back to the artist, right? So it's kind of up to you how you want to interpret the results. But the profile is essentially setting the values that, are important. You notice that there's negative ones that you can set if you don't want to test a particular item. I mentioned that some of these tests can be slow. So if you need beveled edges, manifold edges, we have to reconstruct all the edges. Clean transforms just basically means it's at 0, 0, 0, which is, usually a good thing to set. Triangle count, again, min and max, you might find that if it's not sufficiently complex, maybe you need at least 10 triangles, like, because there's no object in there if you don't have that many. You can set minimums and maximums basically on all of these. As we continue through, we're looking into, kind of the sizing constraints. There's a minimum and maximum that you can set for, overall bounds. So maybe you have an app that's jewelry and you wouldn't expect anything to be, over 50 centimeters, for example. Those type of min and max tolerances, or if you're selling furniture, maybe you don't expect anything to be smaller than, that. Those tolerances can just help you identify, scaling issues. So maybe it was exported 100 units too big or 100x too big because it was centimeters instead of meters. So that can help for the min and max. The percent tolerance actually comes in when you're providing additional product specific information, which is another, kind of optional feature of this. If you're tying this to, your automation pipeline and you have product dimensions available in your database, this could make a lot of sense where, the artist was working with the same dimensions, right? And you'd set a percentage tolerance here that, you want it within. Our recommendation was 3%. But some window of margin of error. Sometimes those product dimensions just, as I know, and we know from working at Wayfair in the past, the way people measure things and get in the system could potentially be the carton size versus the product size, right? So having this as a check, again, it can flag stuff that could need a manual review, but it may end up being perfectly valid. Then we get into some more of the, texture specific settings for resolution, right? So again, different use cases require different things. If you're optimizing small, fast file sizes, or you're populating entire rooms, you might want smaller textures versus if you're doing some type of individual product configurator, for example. So you can set those dimensions. You can set your PBR color range. So this is an interesting one that I noticed when I was testing a lot of assets. by default, they'd fail this kind of specification. But it is an interesting consideration when you think that the PBR, the physically based rendering engine, is bringing in a piece of content and it's adding or subtracting light, depending on if it's in a shadow. I mean, it's typically, basically, I guess it has to add light. But if you've got something that's already fully bright, so like white is 255, right? So if we're talking about the color range, your maximum 255 can't get any brighter, at least not on a standard screen. And so, what happens if you're trying to add a specular highlight to that material, you wouldn't see the highlight, right? So this PBR color range tolerance is a recommendation and, a good practice to basically set your whites a little bit underneath the maximum, and same for your blacks, keep them just, a little bit above the minimum. That way, as light in the scene is kind of being, composited, you can have shadows, shadows on a black surface, for example, I guess is an area where you'd see, not wanting to have all zeros for your black color. So again, these checks are kind of optional depending on your use case, but we've tried to recommend some best practices. Power to textures can also be, more performant for loading things into memory. Quadratic basically means the width and the height are the same. So you might have power to textures, but they could be, multiples of 2, right? You could have like a half texture sheet that's 2000 wide by 1000 high. Gutter width is your kind of UV margins. This one's also marked with slow because it's having to recalculate, some information, but it can also be valuable to know if you've got these kind of, overlapping UVs or islands of triangles that, would, when they scale in, when you, kind of map the textures down, the pixels might overlap and you could end up with some artifacts. So that can, again, be a good check if, it's of interest for your company and you're okay with spending the extra computational time running the check. And, from a timing perspective, I should say, like, running the slow checks can make it, a minute or two. Without those checks, they usually run in, a second or two, depending on the number of triangles. So it is a significantly noticeable impact in speed that you can experiment with your own models for. Pixels per meter is another check that we're doing, also known as like textile density. This is one that I've got some ideas for V2, how we can improve it. But right now it's just kind of like a global setting. So you might want to have, some boundaries around how dense your textures are being applied to the physical object. Okay, wrapping up here on these settings, but UV is not being inverted. So, you want your triangles pointed up. That just kind of has to do with the winding direction. Again, it may be important, it may not be, but usually it's best practice to check that they're not inverted. Overlapping is kind of similar to the gutter, where you want to make sure that the UVs don't physically overlap on top of each other. And the 0 to 1 range is for most of these AR, like web-based 3D models. The recommendation is typically to atlas your texture. So you've got more or less a single material, maybe 2 materials, depending on, the properties. If you've got transmission like glass, you might have 2 materials. But generally, we want to have all your materials baked down into a standard UV 0 to 1 range, rather than have them tiling. Again, that's optional, right? So some people, some products might make sense that you don't necessarily need to do that. But if you're working with USDZ, for example, they only have a single texture UV layout supported. And so if you want to do something like ambient occlusion, you need to have an atlas texture layout anyway. So there are a lot of use cases where that makes sense for people, which is why we added it as a check. All right, so now that I kind of gone through and explained each of those things, you'll notice that there's a big download button here. It's basically going to take all of these parameters, that I can change and toggle and, let's say make that 250, whatever. I change these things and I click download. That's going to download a file, which I'm sharing my whole screen. So I should be able to open that file for you guys. Just pull it up over here. All right, so let's see what this wants to open with. Let's see, open with, oh, it wants to open with Visual Studio. How about we just do text edit? All right, sorry guys, I have a few screens open. I don't know where text edit went. Ah, here it is. Okay, cool. So you notice that this is, fairly human readable. In this particular editor, it's not formatted so nicely, but it's, machine and human readable with all these values. This file could then be, uploaded when we run the validator up top. You can drag and drop your own profile. And this is ultimately, save and close. This is ultimately what we're looking for as I talk about, how you can contribute. We want to gather, these schemas for different use cases. So if you're a retailer, if you're an ad tech provider, if you're making your own solutions, chances are you already have this type of internal validation, maybe not checking all the things that you can check here, or maybe there's some things you're checking that we're not checking yet. But either way, there should be some numbers internally, that make sense to your team that you think, oh, when we see models come through, they need to be, under this size. So we'd love to get that, from the community and then be able to share those with other vendors, especially, if we're making content. The more we can use that content from multiple places, the better. We can potentially also use this information in tooling that would maybe automatically resample your textures, for example. So that being said, that's kind of the main audit profile overview. I'll actually just go ahead and let's refresh and use the default settings. I'm going to just drag a file in and we'll see what we get inside the Asset Auditor code, which I'll look at in a minute, repo. There are a whole bunch of different files. Most of them are fairly straightforward ones. Here's like the Blender monkey, for example. And you'll see I loaded that and it was pretty much instantaneous. I get some results here. A lot of these things weren't being tested. So if we were to edit our settings and maybe turn on some of these things, like I'll turn on some of the slow ones just as an example. Let's say we want, only 4 meshes, but at least one, right? At least one node. Checking for at least one of these is usually a good idea to make sure you don't have an empty file. All right, materials, it's fine. File size, triangle count. This guy's pretty small, but let's give him a minimum. All right, cool. Let's just run that and let's do another slow one too. All right, so if you're using this tool, just make sure you save and continue before you actually run it. Oh yeah, all right, so look at this. So the model had already been loaded and a bunch of these checks got updated. The slow ones didn't because they haven't been recomputed yet. I'm gonna have to reload the monkey here. But that's another thing you can do is if you're trying to tweak pass fail values and the model's already loaded, you can just kind of edit those settings. What I'll do is I'm going to download this one so that we have it now, and I'm going to reload the page to clear out our model. And so then if I go ahead and choose the file or just drag the file up, we should now have that file loaded. Let's double check. Yep. So there's all our file settings. That's good. And then we can load our monkey here. And it's going to be, yeah, there you go. I mean, he's a small guy, so he didn't really notice we increased the speed. But you notice we've got, a bunch of hard edges on him. There's no images, so those couldn't be checked. I'll load one other file that I've got. Let's see, what did I do with that table? I had a table up earlier that I was going to load. To give a more real world example. Okay, let me just turn off. We'll just go back to the, all right. And we'll use that schema, but I'm going to edit it to just disable the slow checks for now. Okay, so save and close, and I'm going to open this mining table. Oh, that's product dimensions. Okay. Okay, so that's loading. And I'm guessing it's still trying to do, I must not have turned off all the slow checks. Reload. Oh, you'll notice that if you're running the slow checks, you'll often get like an unresponsive message from Chrome. I think it comes after like 10 seconds or so. If you continue waiting up to probably a minute or so, it should eventually work. I'm just going to exit it for now and reload that table with just the standard options. And there it is. So I've got a little, viewer here. You can inspect that the model is what you expected it to be. You can see glTF validator is, sending some warnings. I've got some issues with my PBR safe colors. This is actually a version 1 bug that has been fixed, but it highlights other ones like AO, roughness, metallic. Those ones actually don't count in the PBR color safe check. They all failed, but this fail message would only apply to diffuse. So the diffuse file in this case was 0, but the maximum color in this happened to be 160 for the brightness value. You can see other things about the textures, the report, and some of these that aren't actually tested, it still calculates a number, like this pixels per meter, 23 megapixels. It's fairly high, but if you end up with, some small screws or something that take up a decent amount of pixels, these numbers can get fairly large pretty quickly. You see the UVs are in range, etc. So that's pretty much the web demo. I'm going to switch gears to just take a look at the code next. This is actually, this is the asset creation guidelines. So here we go. So on the Khronos group, Asset Auditor, GitHub, this is issue number 1 I opened up. This is how you can submit your own audit profile. But we're going to go to actual code for just a quick overview. So in the code, you'll find that there's the web example that we just tried. So you can build and run this yourself. There's some instructions for how to do it. And if we go back to the main thing, there's also, the CLI is the command line example, which we're going to do next. The web example is the one we're looking at. Source is the actual source code written in TypeScript. So there's a bunch of files in here. If you're a programmer, you're welcome to look at how we did certain tests. Feel free to fork it, send pull requests if you get improvements and changes. There's a test folder that has, some of the models that we're loading, like the monkey, for example, in here. And there's a whole bunch of unit tests that run every time the code's made. So we'll check about 100 different things to make sure that all these different edge cases work. And so inside the GitHub code, there's a description of the checks, how to run the tests. We know there's an issue with Draco compression. So thank you guys who have reported those issues for us. We'll hopefully get a resolution working with the Babylon team over the next few weeks. Anyway, so that's the code. That's where you find it. Lastly, as far as the live demo goes, I wanted to show the command line interface. So that's it here. Basically pulled the code from GitHub, or you can do it from NPM as well. If we list the code, that's it all there. And Eric posted in the chat. Thank you, Eric. And if we go into the CLI example, clear the screen, we can list what's in there. It's basically this index.js file. And you're using Node in this case, right? So the command starts with Node, and then I'm just up arrowing because I've already typed this in before. But you're basically going to run the index file, and then you're going to pass it a schema. In this case, I'm pulling it directly from the test repo. So it's up a directory, it's in tests, schemas, Khronos recommended. And then I'm also pulling a model directly from the test repo. This is a cube that has PBR safe colors. If I press enter, we're going to get a report that kind of spits itself right out. This is kind of the human readable version of the command line interface. You can also have this spit out a JSON file with the results. So that file would then be processed or interpreted, by your internal systems. But you can see we're basically getting pass-fail results, and there's some additional information. Again, this is more the human readable version. You can actually pull this out in the machine readable version, the JSON file that this generates. Yeah. So, in order to actually run this and get this results, make sure when you first pull the code, you do npm I, which installs all the dependencies, and it'll build the project, and then you'll be able to run it. Of course, we've got the issues tracker for any challenges that people run into. We've already, worked with some users on their initial setup. But, I try to keep an eye on that stuff and answer in a timely manner to get you guys up and running. All right, cool. Well, that's pretty much it for the live demo. I'm going to jump back into the presentation. Oh, yeah. I think I was showing you guys that this is I'm not going to go through all these again, but this is just an example of how you can implement the same type of backend code into whatever front end experience you want, right? So you can stylize this as you see fit for your own use and application. All right, cool. So back to the slideshow. That's where you can get the code. And that's an example of the command line demo that we showed. Okay, so kind of as we're wrapping up the presentation portion of this, future development is slated to probably start this summer. Again, we've basically broke this project up and we said, there's a lot of great ideas we have. We can't get it all done in version 1. Let's put something out there and get some feedback. So that's kind of what, this period of time is, right? This is the feedback collection phase. And we're going to be at AWE. So if you guys are at AWE, come check us out. We've got a whole room dedicated to Khronos things. And we'll be doing some live demos like this, as well as kind of brainstorming and collecting ideas about, the glTF format in general. Asset auditors, one of the topics that I'll be discussing, but there's a lot of great, Khronos related topics, OpenXR, Vulkan, et cetera, that are going to be going on at AWE. So that's end of May, beginning of June. And so hope to see you there. But yeah, so I mentioned Draco compression was a known issue. We're going to try to work with the Babylon team to get that working under the hood. There's some requested features such as additional file types, right? Can we load up a USDZ or an FBX? For now, what I would say is, use Blender, open up the GLB and then export it, open up the FBX or whatever file format you have, export it as a GLB, and then you can use the tool. But, additional file types is something that, we believe is important and we'll try to support in a V2. I mentioned for the UVs and some of these other things that could use a visualization like the textile density. That's something that we're probably going to add in where you can get like a 2D, basically a texture sheet, right? That might highlight where the UV overlaps are to make it easier to pinpoint, because it's fine to know like, oh, there was a UV overlap or there were 5 of them, but where exactly in your model isn't always as obvious. Like the Blender default monkey is UV unwrapping has some overlapping triangles in there. And they're very hard to notice. In fact, I was working on a visualization tool like this just to help myself debug issues to make sure that the numbers that we were getting in the auditor were actually correct. So implementing that type of visualization as part of a future release, we thought could make sense. But of course, we want to hear your ideas too. So we can talk about some in the Q&A. But the formal way to do it is just open up an issue on the Asset Auditor GitHub page, as well as audit profiles, which kind of takes me to my last point. We want your audit profiles. I showed you how you can create them, right? You just enter the numbers that make sense for your use case in your company, download the JSON file, save that, and you can post it to GitHub. If you don't want to necessarily have it in that kind of private spotlight, you can also email it to me. My email's pretty straightforward. It's mike@festa.tech. And we're happy to collect these profiles to kind of figure out, one, like what are the kind of commonalities that are out there so that can help inform our recommendations. And, two, if people are making content for your platform, it's in your best interest really to get your specification out there in this kind of open, format, right? So imagine that a lot of these companies that are working with 3D models have those numbers somewhere internally, and they have to run their own internal checks. A part of the reason that we wanted to create the auditor was just to make that more universal and ultimately to make 3D files more universal. Obviously, there are some, differences in use cases. So that's part of the reason that we didn't just create a tool that said pass fail. These are our opinions are what you have to do. We made a tool that's flexible to let, the use case kind of dictate what values are valid. So share your use cases. And with that, we're going to wrap up this portion of the presentation and switch over for about 20 minutes to do Q&A. All right, and then we get our video. So, hey, everyone, Eric.
Yeah, I mean, one thing I thought of recently was, UV stretching, for example. Some UV editors show you kind of a heat map that shows you where the UVs are a very different aspect ratio than the polygons are, for example.
Oh, yeah, yep.
Oh, hey, it's really stretched across the monkey's face, or, that kind of thing.
Nice. Yeah. Yes. As I was thinking about like the textile density calculation, right? We get a number out there that on one of those models was like 23 megapixels or, megapixels per meter. Like, is that a big number or small number? And how does that vary across the surface, right? If you get labels or something, you may want to have a good amount of pixels dedicated to a relatively small area. Versus like if you've got, glass that doesn't really have any detail at all, you might, for optimization purposes, want to shrink those, triangles that don't have any detail into the corner and kind of ignore them. But that's going to, really impact your calculations when you're going to run just a pass fail like number. So having that kind of heat map visualization could be helpful.
Yeah, so we do have one question from Amit Pandey, who's asking, if I wanted to verify the name of nodes in my model, and to the extent of uppercase and lowercase, will that be possible by writing a JavaScript, or in short, how to do that at scale?
Ooh, yeah, that's an interesting idea. Right now, no. I'd say that's something we would add on the V2 roadmap. But I like that. I've, written tools like this in the past, for 3XR and 3D Model Foundry, and naming conventions are important, especially when you're dealing with file systems, people put spaces or special characters. It can really screw up your kind of whole post-processing pipeline. So yeah, I like that suggestion. I feel like being able to quickly rule out naming conventions or enforce a certain standard, for pass-fail check here would make sense. That data is technically available in the glTF file in the JSON. So the tool itself doesn't expose that information right now. You could potentially leverage the existing code to write some JavaScript to basically pull that information. You notice like in the reports, for example, I was pulling out like the texture names and reporting like certain textures that didn't meet, in this case, the color value. So that data is in the file. It does exist. However, we don't currently have a check that would do that.
Yeah, one other thing I thought of is sometimes we get stuff from overseas and it has non-Latin characters in it, like say Vietnamese or Chinese or something that might cause issues in some of our pipelines. And so that's something that we check on when we get high-res assets in. That might be something that we add for a glTF check as well.
Nice. Yeah, that makes a lot of sense. And so I haven't been monitoring questions and stuff, but do you have
so another question we got is how could AI improve automation? Could it speed up QA? Could we use deep learning for asset creation?
Oh yeah, it's pretty cool. I mean, there's been a lot of great advances in AI that well, I should say that are interesting, right? I think the technology is it's on the threshold right now of being helpful and useful in some cases, but then also a little bit more of a distraction in other cases. As an example, when ChatGPT was available in beta or whatever, I was testing it out because I knew they had a lot of GitHub / like Stack Overflow type of questions in there. So I was using it for, learning shader coding in Unity, which I was doing, at the beginning of the year. And at first I was really impressed. I was like, wow, that's a really authoritative answer. Like it knows what it's doing. But then when I'd actually try to run the code that it gave me, it was hit or miss, right? Sometimes it would work. And those were the impressive use cases. And then other times it would, appear to work, but really have like a bug. And then you could paste the bug back in ChatGPT, which is pretty cool. And it would like try to correct itself. But I found that, it was a little bit overconfident in presenting an answer that may be buggy or may not do what you intend. And so that anecdote kind of relates to, the 3D content in that it's a bit subjective. And I do believe there's probably possibility to do something like that with AI. But I would like treat it with a grain of salt in the early stages, right? So maybe use it as a tool to help, filter things or spot check, or maybe you check everything through AI and then you have humans kind of double check it, or use the AI in a more, like you're going to get a lot of false positives, but it's better to double check false positives than let a lot of false negatives through. But yeah, I think, the tools do continue to get better. And, we've seen some interesting use cases for like, Nerf, for example, that can capture content in a way that gives you multiple, perspectives of a piece of content. So I'm thinking that might be a way to check your 3D model, right? So if you have a 2D image photograph and a 3D model, today, a lot of times we do side-by-side kind of renders of the two. And as we discovered when we were trying to do scene viewer validation, just checking on a per pixel, basis, it doesn't really give you good results. But maybe applying some type of like machine learning or AI that would be trained on enough like, good matches versus bad matches could actually work pretty well. And if you get, multiple camera sources, maybe you could even, get more coverage of your model than you would, traditionally.
Yeah, so we got another question from Pratish is asking, wondering about, can we integrate our custom validations like checking mesh names, or can we upload multiple models at once and perform on a single use case?
Yeah. So yeah, just to answer the second part about doing multiple models, that's essentially what that command line interface was for. On the web viewer though, too, if you were going to do a custom integration, there's nothing stopping you from processing multiple files. Both code bases use the same, module, JavaScript module. It's just that one does it in the browser context. So there's a few things that happen differently for like loading in files, for example. There's certain things that are available in a browser context that aren't available in Node and vice versa. But we try to abstract that so that you could basically batch process files in either one. But you would have to basically implement that on your own. So you just create an asset auditor, object, and then you can, load one profile and then you could continue swapping in models, for example, to get those results. So yeah, totally possible to do that. On the naming convention, no, but like I said, I think that's a great feature for V2 that would make a lot of sense to add.
Well, here's another question. What future work gets you the most excited?
And that's interesting because there's there's a lot of stuff happening out there. Like I said, like in the AI side of things, like Nerf is a pretty interesting technology. I've been doing photogrammetry for a while as well, which, Nerf to me is a potential replacement for the photogrammetry process. Photogrammetry requires, let's say, 2 or more cameras that are looking at the exact same point. And based on kind of, features of, pixels, essentially, it's trying to match and figure out where that is in 3D space. Nerf is just kind of an entirely new process, a new way of thinking of things that has some really fascinating results. And at first, when I've, seen Nerf and or other kind of, let's say, those types of like holograms or things that were created from multiple cameras but don't have any mesh information, those always kind of made me a little skeptical because it's like, all right, this is, an interesting visualization. Maybe there's a point cloud, or maybe there's some, in the case of Nerf, just like pixels fed to the screen based on the camera position that don't necessarily, like, it's hard to like wrap my head around the traditional, like, all right, we've got a solid physical triangle in space that has a material or a texture applied to it. Like that's kind of easy to imagine, whereas some of these technologies that just spit back pixel information based on the camera position are a little bit harder to kind of wrap your head around. But what did it for me that made me feel more excited about this technology was seeing that mesh creation from a nerf. So like nerf to mesh. To me, that felt like, all right, that's like practical and useful today. You could use, an iPhone, let's say, to capture that nerf. You're moving your camera through space. The computer's building the 3D representation in its own mind. But if the computer representation can then be exported out into a 3D mesh that can be edited by an artist or played in a regular viewer, it feels like it has a lot of, impact in the near term. So from a 3D perspective, that gets me pretty excited. How about you, Eric?
Yeah, I think the same thing. I mean, the nerfs are really cool because they can handle really fine details that are not easy to generate in a 3D model right now, at least for real time. So like, for example, fur or feathers or
A lot of stuff in your background back there, all those leaves,
Yeah.
and,
Yeah, right. Like nerfs can do that really well. You can get all that kind of fine detail, or at least an approximation of it, and converting that into mesh is not that great. So that's something that it's really strong at. It's just like you're kind of stuck right now with the lighting that you captured with, and overriding that's a little more difficult. So you kind of have to extract, the color from the lighting and kind of do some more, processing on the file to make it. So for example, if a customer captures their space, we want to probably remove existing furniture from their space, so then we can add new furniture with AR on top of that. And so that's really intriguing now. There's a lot of research there around erasing from your room and kind of auto, like Band-Aid filling in, existing space to get back wall texture and floor texture. That's really intriguing to us.
Yeah, totally. I'm not going to talk about it too much yet because I'm going to be announcing things in probably a month, but this Paint Fiesta app that I'm working on is a mixed reality app, essentially, where, we're able to do some of those things, right? Blending your real world surroundings with digital content, and I'm, generally excited about the direction of, headsets. Obviously, I've got headsets behind me here. I've been doing this stuff for over 10 years now. On this side, here's my original DK1 Oculus that I had Palmer Luckey and John Carmack sign. So I've been doing this from the beginning, or at least the beginning of this VR cycle, right? There are folks that I know that have been doing it for decades, back into the 70s and 80s. But anyway, I'm more of the modern, VR headset evolution. And it's been interesting to see, especially now with this kind of like pass-through capability, the hand tracking, the devices that are just coming out now, and, hopefully like the Quest 3, maybe Apple's going to have something to announce soon. These emerging devices start to make some of these, ideas that we're thinking about, Eric, here, more tangible. And then, the hardware problem I feel like is kind of solved. Now it's a software opportunity. And as a software developer, I'm excited to be in this kind of space where the hardware's there. It's just a matter of, using our imaginations to create some cool experiences.
Yeah, so that brings up a related question, which is, if you're creating Nerf content, how do you QA that at scale, right?
Yeah.
Is there stuff from that you can extract to figure out, oh, hey, maybe the edges of this thing are too fuzzy because you didn't capture at a decent enough resolution, or machine learning didn't quite understand what this surface is. Could we see a way for Asset Auditor to handle Nerf files?
Yeah. Oh, that'd be interesting. That's probably going to be V4.
Yeah, a little further out, maybe.
Yeah, but no, it's still good to think about. And I would say in the 3D commerce, group that we have, we try to balance the needs of now with the needs of the future. And so Nerf is one of these topics that kind of comes up every so often, and we kind of check in and say, what's the state of this? Is this still in the research phase? Yeah, probably. But, we want to start thinking about, how do those file formats kind of get transmitted? Right now, everybody kind of has their own proprietary way of handling it. There's not really, a universal like web viewer. There's not a glTF, compatibility, style. So that's something that, as a group, we'll probably be on the front lines of in the future. But, just in general, 3D commerce is looking to promote a lot of the technology we have today, especially on the PBR material side. Like there's some pretty nice looking extensions that are part of the glTF 2.0 spec. And we're trying to come up with ways to, certification was kind of one of the ways we described this in the past, but we want to have, a set of standards that companies, people that build and develop and deliver these experiences to end users can kind of have as a minimum, requirements. GLTF 2.0, which has been out for a number of years now, has, certain standard things that, we're checking in the auditor right now, right? So like your diffuse textures or, having your AO map so that it lays out nicely. But there's some additional things that, we're seeing, irradiance and whatnot. Do you want to talk about any of that, Eric, before we wrap up? Just some of the cool material features in PBR.
Oh, there's a whole bunch of stuff we could go over there. I get, somebody did ask another question in chat there.
Okay, cool.
And they're asking, can we integrate FSpy in the future to find out camera details and orientations from 2D reference images? And I'm not familiar with FSpy. Do you know FSpy?
I don't know FSpy, but I think the concept is definitely one that's come up internally around the GLTF file format is, can we have an extension that would allow for camera information to be included in the GLTF file? And it seemed like there was a lot of interest in that internally. It would be an adjustment to, the GLTF spec per se before we could do it in the auditor. But yeah, the idea being if you're doing something like photogrammetry or NERF or whatever, you've got these real world camera positions and references that you can then potentially render the 3D model in the same orientation and scale and, camera focus perspective to generate a comparable, A/B test. And then maybe the AI plays into that, right? Once the AI can, instead of trying to pixel perfect match it, have some other, fuzzy match that it can calculate internally. But yeah, having that information in the GLTF file is something that would be added as an extension, and there was interest in that from the group. So thanks for the, the idea and the support. We'll try to continue to pursue that. Cool. All right. I want to make sure I give Jeff enough time to wrap things up. I know he's got some announcements. So I think with that, we'll say thank you guys for coming. Again, follow up on GitHub or via email with us. If you've got specific profiles, please share them. If you have questions, also happy to help there. All right.
Hey, thanks, Mike. Thanks, Eric. Thank you for all your time and effort in putting this presentation together. We appreciate it very much. As a reminder, a recording of this presentation along with the slides will be available on the Khronos Group website, and a direct link will be sent to you in a follow-up email. As Mike stated earlier, please join us at this year's AWE. Khronos will have a dedicated forum for Khronos-related sessions. GLTF and 3D Commerce are featured on Thursday and Friday of that week. Check out the full schedule on our website. Separately, if you're interested in presenting at April's GLTF meetup, please contact us at events@khronosgroup.org. As you leave this webinar, please take a moment to fill out the survey that pops up. Your feedback is important to help us improve these presentations, and please let us know if there are other Khronos-related topics you may be interested in. Thank you for joining us. We hope you enjoyed the webinar. Have a great day.